Okay, so in this lecture, uh, what we are going to discuss is about the first implementation example. So this example is about a Java hash table. Okay, so totally we have four files, a book class file and a hash table interface and the hash table class and the driver. Okay, so the first is a book, and the book class is pretty straightforward. And so the book class implement both clonable and comparable interface, has just two instance variable ID and name. Okay, and then has a get method, set method, compare method, and it also override the equals method and the hash code. Okay, so the hash code is new. What it does is just call objects as a hash and plug in both instance variable. So this is the hash code. And then let's see the hash table interface. So hash table is an interface, okay, and it use key value pair. So that's why here we have this two generic. And it has three abstract method: insert, lookup, and remove. Okay, so insert going to insert both key value pair. Lookup just use key. Remove also just use key. What both return is return this entry basically is a key value pair. Key value pair. Okay. And then let's see. Okay, and then within this hash table interface, we define a static inner class entry. Okay, so what it has two fields. Okay, key and value. Okay, and then we have the get key and get value okay, and the constructor. So pretty straightforward for this entry. Basically, to take care of the key value pair. It also has a respective output to string method. Okay, and then next, let's see. So here we define our hash table class. So it's going to implement that interface that we just defined. And for this class, it has a constant capacity, also has an array of linked list, and we name it as buckets. Okay. So for the constructor, what it does is initiate the capacity and also create the array of linked list. So this is the array of the linked list. Okay, and then what else did it do? So it insert method, lookup method, and remove. So first, let's take a look at the lookup method. Okay, so lookup is to search. So using key to see if the specified record is in this hash table, is it? So what it does is using key to find the hash code and the module to find the index. Okay. If you recall in our first lecture, we explained then based on the key of apply hash module the array size, you can find the index. Okay. And if the specified at that specified index, if the array here is a linked list, if the linked list doesn't exist, is it? So here. So that means you cannot find the item. So that's why it return null. Okay, that means not found it. And otherwise, that means you find it. That if this bucket index is not null, that means it exists. But it exists where it is, what its value is it? Because it's this one is a linked list. Okay, so it's a linked list. So it's a linked list, so that's why over here we need to do one by one comparison. Okay, so from you get the key and then you compare is it okay to see because you look up this key, you compare the key. Okay, each item by item, you do the compare. And once you find it, then you can return this entry. Okay, return this entry. Okay. So that's what lookup does. Once we understand the lookup, then we can also take a look at the remove operation. So for the remove, this part is basically pretty similar as a lookup. Because when you do remove, you first try to find the item, is it? But once you find it, here the difference is it's going to remove that item. Okay, that's what it does. And we also implement this whole hash table output. Okay, so we loop through the array, and for each array, it's a linked list. Okay, so then we just output the contents. Okay, and then let's take a look at the insert part. So for the insert method, what we do is you first try using the key to find its index, is it? So if it's null, then you need to create a new linked list. That means it doesn't exist. Otherwise, that means that item is already in the hash table. So we need to try to find it. Okay. Once you find, because you want to insert, that means you want to update the value. So what we can do is, if it's the item, is it? Find it, then you find the value. Okay. If the value is not the value that you want to insert, then you update the value. So here we update the value. Respect. So with respect to this specific key, you update it. Okay. And otherwise, okay, that means for this new item, is it? And you need to create a new entry, then add it. Okay, then that means we insert successful. So that's about insert operation. And then let's take a look at the driver part. Okay. So what the driver part did is it first tried to create 8 books, okay, using an array. Then you create, here we create 8 books. Okay, and what next we did is we create a hash table, okay, with 8 items of the hash table. The hash table key is a book, and the value is a double, okay? So then what we are going to do is So we are going to add book by book and their price to the hash table. Okay. So we add all 8 books to the hash table and their price. So basically here, key is book, value is book price. Okay. After we insert, so after we build this hash table, what next we can do is we can try to find to see if a book is there. Okay, so here is a book. Okay, and we can also to see if we can remove some book. Okay, and after we finish look up and remove, then we can output the whole hash table. Okay, then let's take a look at the output. So here I try to find the book. Yeah, it did find the book. It look up the book and find the price. Okay. And yeah, it did remove the book. Okay. After that, we have all of the remaining books. Is it? And clearly here we can see, you see, the first linked list. Basically, this is the first linked list. We have 2 books, is it? And all of the other linked list, we just have a single book. So here, basically, it's these 2 books, they have collision. If you recall, is it that hash table collision? Okay, so both got the same index with different key. Yeah, clearly, is it why is this book? Why is this book? These 2 key are completely different. Okay, but the index is the same. So what we do is, because we use a linked list, so we can store them in the linked list. Okay. So then in this case, when you do search, it's not purely just order of constant, is it? So it's order of constant for the index part, but when you do the linked list, then it is also, so the order of like n, okay, based on the size of the linked list. Okay, so that's our first coding example, and for the second one, we are going to discuss it in next class. Okay, see you.